So in this video, I'm going to show how Java uses iterators already. So I want to come up with kind of two examples. I want one from JDK, and I'm going to show the enhanced for loop, it's called, and then I'm going to show one from JDBC, which is for Java database connections. So the iterator pattern, we have this get next while there is more. So often we combine that with a while loop. So let me show you here. So in this project here, I have this database transaction example. And if I go into, let's see, where do I have that? Main method, sorry. If I go into the main method, we can see that I have something. It's pretty convoluted with all this stuff with transactions, but bear with me for a second. I'll show the important points in a second. So within JDBC, what we can do is we can set up a SQL query like this, put some parameters in there, and then we use this command for executing the query. The important thing here is then we get something called a result set. And a result set is all the rows and columns from the database that we actually load into this result set, so we can actually work with that data. And we don't know how many items are in this result set. So if we have a result set that looks like this, we have some columns, we have an ID column, maybe we have a name and we have a phone number, and then these are just kind of the header. We don't get that, we just get the data. And then in here we would have ID number 1 with the name here, something, and then we would have the phone number here, and then 2, something else, phone number here. So what the result set really is just a collection of rows in a database. And when we start out having a pointer to kind of nowhere. So we have an iterator built into this transaction example, and that iterator will point to nothing in the beginning. So when we call this method here called rsNext, and we can see that from here, this is the something like get next, except we don't get the real. Let me show here. So what rsNext does is that it points the result set internally. Inside the result set, we have saved the state of that result set, and when we do rsNext for the first time, it actually moves to the first row in the database result. So first it goes to the 0th row. So if we were to just say get the data from this row, we would have some errors. And when we do rs.next, what it does, it moves its internal pointer to the next element of this list. So that means now it's pointing to the actual first row, and what we are actually selecting here is the amount. So we only have one column here, but we have probably also only one row, but it looks at the first row, and then we can actually say rs.getFloat, and then we're going to say we want to get a floating point value from the database result, because we know it's a floating point, and the label of that's the name of that column in the database, will be amount. And we'll save that into our balance here, which is just a variable here to save that balance here. And then we do some calculation and sleepy time and stuff. That's not important. But the idea is when I do this rs.getFloat, I will get the first row and the value for that. Then I used an if statement here because I know there's only going to be one row. Normally we would use a while statement for this. So this will keep returning a Boolean, and it will return false when there is no more no more rows in that result set. So from the beginning, it points to nothing. And at some point, when I say rs next, it knows that there are no more elements down here. So it will just return false. So this way we can iterate over all the different rows in the result set without knowing how many there are in this result set, and it will also go through them exactly in the order that they come from the database. And when we're working with databases, it's very important with order, because oftentimes when we do SQL queries and stuff like that, we would do something like, we could say order by I don't know, age or whatever, some other column. So we often want a specific order of our data, and it's important that they come out in exactly that order. So when the result set iterator is iterating over this, it's going to do it in the order that they come from the database. So this is one example just to show you that this is a very common pattern that is used. Better put that back, but this is a very common pattern used for the iterator pattern. So you could imagine you could get something like a for loop, and you can go to the length of or something like that. But this is pretty handy for something where you don't know the length and you don't care about the index of that in the database. So the other thing I wanted to show was from Java itself. This is the what I call the enhanced for loop. So it's really the same as using the loop like this. So what the for loop here does, the enhanced for loop, it pretty much does the same as the normal for loop, where we would do something like this. And if we want it to be exactly the same as above, we can do like this and run that code. And we can see that this is from the first part. It prints out the numbers, and the second part does exactly the same thing. So these two are equivalent. So whereas there is no iterator built into this one, the enhanced for loop actually creates an iterator for this kind of collection here. Really, in the background, when we're working with the simple data types and arrays, it really just converts this into a for loop, if I remember correctly. But for it, the for loop also works for any other collection where it actually creates an iterator. So this is an example of the iterator pattern. We can also write this in another way. Let me show you something interesting. If we say for, and then we say iterator, and then we put string, no, not like integer, and we call that I, and then we're going to say something like this. And then we want to take something that is iterable. So we could say like this. Wow. And then we could say I has next. There's a meaning to this craziness. So what it actually does here is it converts the array into a stream and then creates the iterator on top of that. So this just shows how we can have the internal iterator. We can see that, and then we can do like this. So now we can write something like and we can set that to I next, and then we can set system out print line, X. And we can see that this does exactly the same thing. So this will actually take an iterator and then call the hasNext method each and every time. We can also rewrite that. We can say like this, iterator. Maybe I should rename this. It's a bad name. I'll call it iterator instead, not to confuse it with I. Another way of doing is we could type while, and then we could have something like this, iterator. So we define an iterator out here, and then we could say while the iterator hasNext, while there is more to it, and we know it's integers, we can do like that. So this way we can get iterators and see the actual iterator over this and use it like a normal iterator. So this is the iterator pattern. So what we're really doing, normally we have outside or external iteration when we're doing a normal for loop like this. And then we can have internal iteration when we do the enhanced for loop, or we go and explicitly create an iterator and then just loop over that collection using the iterator. So what this really does is it uses something called the Iterable Interface. So this is why, because this is just a simple integer array, I have to kind of convert it into an array before I can get the actual iterator for that. Because if we say my array, we can't really just get the iterator directly like that. We need to stream it before doing that. But if we have some other collection, let's say like a list or something, oh, sorry about that. Let's just use an array list for that. And of course we need to import list and array list. So if we take int list, then we can just write iterator directly like that, and we can do that with any of these kinds of lists. So if we look at the list interface, we can see that it extends collection really. So if we look at the collections interface, we can see that that actually extends iterable. And iterable is the actual interface that we use. And interface iterable is here by itself. So what that does is we can return an iterator, and then it has these cool features like it can do for each, and it has something like a splitterator, and this is how it can actually work. So yeah, so if you want to create your own iterator like that, you can actually use this interface for that option. So if we want to do the same thing as up here, we can get the iterator like this. We can say iterator equals int list, and then just iterator, and then hasNext, and this way we can get the next element. And you probably saw there are also other kinds of it here, because this is a list. There's also like this. iterator here. So of course we would need to go through this, and of course now this integer list is kind of empty. So we would need to fill some data into that for that to work. I'm not going to do that. Basically, we just fill these values in here, and then I don't know, arrays as list, and then we get into some problems with the. It says because this is not an integer array, it's an int array. So then we can do it. Let's try again and then see. So, oops, no such element exception. So I did something wrong here. Let me just see. Yeah, so I think, of course, I'm using the iterator from this stream up here to iterate here, and because it has internal state, I get into problems. I already reached the end up here because I called iterator next for each element. So the first time I call it down here, it will, because it references this and not really the iterator for the list that I created, it will fail, of course. So now they do the same thing. So you can see it just does exactly the same thing. Yeah. So this was just, maybe it was even more about the enhanced for loop and lists than it was about the iterator pattern. I just wanted to show that this is a very common pattern, and it's not only used like this, you'll see it everywhere when you're working with different libraries and Java itself. So then my last video, the next one, I'm going to show how to implement your own iterator.